Hello everyone. Last video we have discussed a distance time graph and velocity time graph when the object is at a rest condition. In this video, we will discuss when object is in uniform motion or uniform condition. For that, we will take one simple example. Suppose morning 10 a.m. I am starting my journey. I am driving a car, and when I am driving a car, so one important thing for uniform motion we are considering velocity is constant. And velocity is nothing but change in displacement or change in distance divided by time, right? I am thinking about distance versus time graph. So as an example, what I said, I'm driving car. Suppose morning 10 a.m. I have started my journey. As the time when I will start my journey, that particular time is zero. Distance covered or distance traveled is zero. Now, after 1 hour, I have covered a distance of a 20 kilometer. Every 1 hour I am traveling a distance of a 20 kilometer. The distance I am covering every hour, it is fixed 20 kilometer. I am not reducing it, I am not increasing it. So the rate is fixed for 1 hour, 20 kilometer. For 1 hour, 20 kilometer. Right? So like that, if 10 a.m. distance is zero, because I have started the journey. 11 a.m. I have covered a distance of 20 kilometer. 12 p.m. I will cover a distance of 40 kilometer, 20 plus 20 kilometer. So 20 plus 20, 40. After a few more 1 hour, 1 p.m. if I check, I have covered a 60 kilometer because additionally 20 kilometer I have covered. So like that it will go. The logic is every 1 hour I am covering additional distance of a 20 kilometer. So if I plot the graph, just for understanding, we have divided the time interval. The time interval I will show in green color. So this time interval, first hour I will say, for first hour I have covered a distance of 20 kilometer. Again for next 1 hour, additionally 20 kilometer I have covered. For the next 1 hour, I have covered additional 20 kilometer. For the next hour, additional 20 kilometer. If I see in this graph, in this plot, what I will observe is change in displacement divided by change in time. If I take the ratio, what was my change in displacement? 20 kilometer. And what are the time interval? 1 hour. So if I take the ratio ds divided by dt for any time interval, for this time interval, for this time interval, for this time interval, for this time interval, for any time interval, if I take the ratio of ds divided by dt, it is fixed. How much it is? ds was 20 kilometer and dt was 1 hour. So ratio was 20 kilometer per hour. That ratio is throughout the journey is constant. So like this line is actually, it is indicating that velocity, which was 20 kilometer per hour. Anywhere for this line, if I take the slope, if I calculate the slope is the same. Value of that slope, it remains the constant. So like this motion is a kind of a uniform motion. So this is about distance time graph. Now if we think of velocity time graph, we know velocity is equal to change in displacement divided by time interval. For particular time interval, how much change in displacement has happened, that ratio, it indicates the velocity. Now in our case, through this graph, we came to know that the velocity is constant irrespective of the time. Even though time is progressing, time is increasing, velocity is constant. So for this, we will take one more example. Suppose I am traveling, I am driving the car. Somewhere, some point of a journey, in between the journey, the person besides me, he asked me what is the current car velocity. So I will tell him, suppose 20 kilometer per hour. Then again after 1 hour, he asked me, now current velocity. Still I will reply the same, 20 kilometer per hour. Again after 1 hour, he asked me what is the current velocity. I will tell him 20 kilometer per. So that velocity, irrespective of after how many hours that person asked to me, irrespective of that, my velocity or the car velocity is the same, which was 20 kilometer per hour. Same thing if I draw graphically. When somewhere in the point of a journey, this time the velocity was 20 kilometer per hour. Again, after 1 hour, suppose velocity is 20 kilometer per hour. Again, after 1 hour, still velocity is 20 kilometer per hour. Again, after 1 hour, velocity is 20 kilometer per hour. Again, after 1 hour, velocity is the same 20 kilometer per hour. So if I connect the points, I will get a line, a straight line, which is parallel to this time axis or which is parallel to the x axis. So this is velocity time graph for the uniform motion. Now, if I compare the distance time graph and velocity time graph, the nature of the graph looks the same, but the thing is, their understanding is totally different. Here, this graph indicates the object is at a rest condition, and here it indicates the object has a velocity. Here, the object is not at a rest condition, it is moving, and here for the rest condition, this distance time graph, it indicates the object is at a rest condition. The graphs looks the same, but their, I will say, their understanding is totally different. For what message they are giving, they are totally different. In the next video, we will discuss about non-uniform motion. Thank you.